the platform is highly scalable. It scales statically as well as dynamically. So there could be requirements that if you're not aware of the processing requirement that your operator need to handle, but if you can provide it the resources ahead, then this is the dynamic partitioning is the way to do, because depending on the latency and throughput requirements, it can scale up or down the partitions at every level in your application. So the platform is highly performant. So we have seen use cases for fraud detection and for credit inquiries for one of our customer, where we have achieved millisecond end-to-end latency in the platform, in the applications developed using this platform. And the application is highly fault tolerant. If a node goes down or if certain container is killed, the application takes care of automatically recovering the killed container, and it guarantees that the state is also recovered and that way it's stateful. So the way it guarantees that the state is recovered is, so there will be a checkpointing interval like for every 60 windows or so, which is configurable. So once the checkpointing is done, at the 60th window, if the application fails at 70 window, the container falls back to 60 window, thereby resetting all the downstream containers as well and replaying the tuple starting from 60. Yeah, and there are like operators readily available in Apex Malhar library, which have many useful operators like a Kafka input operator, for example, HDFS input output operators, Cassandra input output operators, MongoDB connectors, and Redshift operators. There are like multiple. There's a huge library of operators available. Depending on use case, you can. We suggest you to look at the Apex Malhar library first. If there is an operator available in Malhar, we suggest you to use that because it is tested by our team here at DataTorrent, and most of the operators are production grade. And Apex platform is native to Yarn and Hadoop. So it uses Yarn for resource management and negotiation, and it uses HDFS for checkpointing and bookkeeping work. So this is how the Apex platform sits on top of Hadoop. You have the Hadoop Yarn plus HDFS layer here. On top of it is the streaming runtime platform, which is Apex platform. On top of Apex platform, you can either use operators from Malhar or create your own custom operators and develop your streaming application on top of Apex platform. On top of the Apex platform and Malhar library, there is a graphical application design and launch. There are data visualization dashboards and management console when you have DataTorrent package with it. So having DataTorrent makes your so the management becomes easy with DataTorrent console. So what's an Apex application? An Apex application is a directed acyclic graph. So consider the components, vertices, edges, and the meeting point of vertices with edges. The vertices can be referred as operators, and the edges can be referred as streams. Whereas where the vertices and the edges come to connection, that is where the ports come into picture. So an operator is like users business. An operator typically encompasses users business logic, or it could be from an operator from Malhar, where we say that the operator's function is to connect to Kafka. Connect to Kafka as a Kafka consumer and consume messages from Kafka. It's just an example. Or your typical business logic operator could be like aggregate over a certain time period and enrich the data, slice and dice the data, right? So that could be your business logic. And a stream is a sequence of data tuples which connects operators. So the first operator could do parsing, the second operator could do enrichment, where the third operator could do filtering. You need the data to be flowing from your parser to enricher to filter, right? So there needs to be a stream which is flow, and the stream connects to the operator or an input port, and it leaves the operator or an output port, right? So this is the terminology of stream, operators, and ports in an Apex diagram. And Apex is like we discussed before. Apex has native Hadoop integration. It uses YARN as its resource manager and HDFS for storing any persistent state, like dismounted state or any bookkeeping stuff. And if you look at the picture here, just like any other job which is running in the cluster, there could be map-reduced jobs, Spark jobs, or Hive jobs which are running in the cluster. Along with that, there will be DataTorrent jobs which are running, where there will be a streaming application master here in green, Stram, which takes care of, which requests the YARN for resources, and YARN allocates resources in different nodes for the streaming for the application, and streaming application master takes care of coordinating the containers. And if a certain container fails, then it goes back to the resource manager and asks for resources again, right? And there is DT console and DT gateway, which is on top of the Apex platform. There is an Apex CLI as well, which will give us the same information, but it's from the command. So the use case for the GPS tracking app alone, these are not, this is one category of Apex applications that we build, which is GPS tracking. So for the GPS tracking app, the use cases that we have seen or identified are many, but we have listed a few here, where you can track fleet vehicles when they're in transit for any kind of information that you need to know. Say, for example, Walmart could be keeping track of the trucks that is taking load. It might mark a boundary and say, like, okay, it should not go beyond this boundary, right? So that's one use case to track fleet of vehicles, or for any kind of frauds that's happening. And bus tracking for government private transportations to adjust routes dynamically according to traffic situations, right? The same information can be used. You can put a device or a collar on wild animals or endangered species to track them and take necessary steps needed for them. And if there is a showroom, a car showroom, and there are like an inventory of vehicles there in the showroom, then the manager might decide to track each and every vehicle just to make sure that it is present, or it has not gone beyond a certain zone at a given point of time. So that's one use case, like track inventory of items including cars, refrigerators, expensive retail goods, etc. There could be location-based transportation apps like Uber or Lyft, where when the person requests for Uber or Lyft, there will be a 2 kilometer radius which would span and identify all the vehicles under the 2 kilometer radius, and a request will be sent to those Uber drivers, and depending on whether he accepts or not, a driver will be allocated for you. So something similar. Location-based gaming apps like Pokemon Go, which needs no explanation, and there is location-based utility apps like Find My Friends, where the GPS tracking, where your mobile device continuously sends data and gets tracked. So these are some of the use cases that we have written, but this GPS tracking has like, there are many use cases for the GPS tracking which we have not listed down here. Depending on the use case, you can look into the app. Okay, what do you become?
Thanks, Venki. Thanks, Venki, for the explanation of the use cases, and and a brief introduction about the Apache Apex. So yeah, if you have any questions, guys, please raise questions in questions forum. So I will continue on the general requirement for the apps and the app architecture now. So I think based on the scenarios what Venki has provided, the general requirement for GPS tracking apps is it's basically you have to accept the data from the devices, then process that data in real time, and identify the various trends on the events happening with the device, and inform the customer right then and there based on the severity of the particular event. So in general, we can state the requirement as that we need to accept the data from millions of devices either through TCP sockets or over MQTT protocol. Once the data is ingested into a system, what we need to do is like process it, apply some kind of a rules to identify if that is the kind of a event or what kind of event it is, and as well as the severity of the particular event. Based on the event priority, severity, we need to inform the customer that if that something is going wrong, or what is exactly happening with your uh, basically tracking device. So there might be scenarios where you have basically, let's say in case of wild animals, when they have the collars, they might come into the vicinity of the uh, have villages or any human civilization, and it may be dangerous to those kind of wild animals. So the appropriate group should take action as soon as possible before any kind of harm happens to those animals. At the same time, when you have an expensive good and your driver is basically your truck driver is trying to cheat you, or he's going off route from uh, well-defined route. So there might be scenarios that that particular truck is already like hijacked, or maybe it's like driver himself is kind of uh, committing some kind of fraud over there. So you need to take care of this kind of scenarios by interrupting the driver at the same time. So this kind of a crucial scenario need to be informed to your customers at very same moment, but at the same time you need to process the historical data like for the analysis. For example, in case of if you have a pet and he's wearing the GPS enabled collar, so and the pet goes missing, so you want to track the pet till the time last location. So last known location for that particular pet. So those kind of things are only facilitated by kind of providing historical data, so you can actually filter down your search to a particular area instead of looking everywhere. So that's a kind of a general requirement for the GPS tracking app. So we actually leverage the Apex platform itself to develop the application for basically GPS tracking application. So so everything what is needed was actually hosted as a operators inside various Apex applications. So we'll go into details of what are the different applications we actually end up developing and what are the different operators were needed to facilitate this requirement. So general architecture of this application will look like you are receiving a data from the GPS enabled devices. So where your Apex apps can be running on the Hadoop, which can be either on EMR or any kind of a cloud infrastructure, or it might be on your on-premise servers. And on the other hand, where you have a web client, like for example, customer care, panel, or it can be a mobile client for the end users, so where they can actually track the different their devices through the mobile apps or the web apps. So this is overall application architecture. So we'll now go into details of this. So, so more like what we did is like we ended up creating multiple applications from this architecture. So we primarily have a kind of a two parts to the application where we are providing a data for UI to render, and at the same time we are also receiving data from the devices and processing it and make it actionable for the in mobile clients and the web clients to present them to the end users. So we provided the HTTP REST API support in using a new operator what we developed in the process, where customers can plug in their newest REST API implementations and basically use it to provide responses to their various APIs for the web client and the mobile client. So at the same time, we wanted to provide a real-time push notification of real-time updates. So on those mobile and web client. So we also ended up providing a WebSocket support with the newly developed WebSocket output operators. These things are not available in Malhar as of now. They might be eventually, but this is more of a proprietary code for the DataTorrent. Then basically what you receive are device data from the millions of devices using a TCP socket. For example, in this particular use case, what we are expecting is that we are going to receive a data at every 1 minute from roughly million devices. So we kind of design the what kind of device data, the structure of the device data will look like. So it will be pretty much like a location and the device identification, plus the various information like temperature, pressure, and the battery status. So this kind of thing even be used in some kind of a factories or oil rigs where they have multiple sensors there and they want to feed the data back to the system. So we can make the basically run some algorithms on top of those on top of that data and decide whether it's anything going to fail. So we can get the warning before it actually fails. So so basically the app looks like you are getting a data from the TCP, and then we are going to parse and process that data to make it actionable in real time and store that data with the WebSocket output operator. So so one crucial thing what was useful for was needed is how we should store the state for each user. So in Apex application, the operators can be stateful, and the state restoration is actually taken care of by platform itself. So using the checkpointing mechanism, so we kind of leverage that. So instead of having some third-party database, we actually end up using the data structures what we developed for storing the states. So some of the data structures what we have is also backed by the HDFS. So you don't have to basically we don't have to hold the whole state if not being used all the time. So that kind of helped us to reduce the memory footprint for these operators as well. So what this is basically now this is kind of a over app architecture looks like where it receives the data from devices and make it actionable for using the WebSocket output operator. So here the GPS enabled devices sends the updates every 1 minute to a data receiver, which is a TCP socket input operator, and the TCP socket input operator then parses this particular data which comes in, and it sends to a geo event identifier where which is responsible for identifying if it's a critical event or just a regular update, some and which user it is for, or as well as the what kind of other information which are needed to make it more useful. So like user information, device information, and the last location of that particular device, all this data is kind of clubbed together in the geo event identifier to decide whether it's a some kind of an event or not. Based on that, updates and the events are actually pushed to the WebSocket output operator, where they are holding memory for the user to actually connect and retrieve that information. So what we did for the WebSocket output WebSocket application, so we kind of ended up developing two application. So where you can have a load balancer like Nginx or AWS load balancer, and then they can connect to the WebSocket load receiver. So Nginx and other load balancer are more or like a round robin load balancer, so they can connect to any of the load receivers. But since our WebSocket output operator were like a stateful, and they are partitioned based on the users, so we wanted to ensure that the request for the particular user goes to the particular operator. So we ended up developing kind of two applications. One application is just to receive a request and forward them to the appropriate output operators. And on the output operators are actually part of the GPS tracking app, what we saw in the previous slide. And so you can see here the user one in data is pushed to the first partition. At the same time, user one request from the WS load receiver also sent to a first partition. So that's how we kind of managed states for the users. And the similar approach we followed for the HTTP servers, where whenever the HTTP load increases, we can actually increase the number of partition in the HTTP load receiver based on the load, while on the HTTP session manager, which is basically responsible for holding user data in memory, can be partitioned based on some other criteria. So based on the memory usage, or based on the how much is the turnaround time is basically in memory cache which you are holding. So so this kind of architecture we created. At the same time, the session manager actually can talk to the database directly and get the whenever the user is logs in, so we need to update the user information from the database, like the first name, last name, all this, as well as the provide authentication for that user. So those are credentials, and the passwords, all this are actually stored in the database, and all the updates are generated using a database. So there are certain things which we need to communicate between a session management app to the GPS tracking app. For example, some kind of a update happens on the user side, which are crucial for the device tracking. So we use the Kafka to relay those updates to the on the GPS tracking app side. At the same time, suppose a scenario where user is no longer active on, and or maybe the connection is kind of broken on the WebSocket server, we need to inform that to a session management app. So your session management app can actually bump out the user from the system. So the next request it receives, it will basically kind of log the user out from the both web and the mobile clients. So, and for the data persistence, we each event, each basically update from the devices we receive, it's basically enriched using data from the Cassandra. So we have our own Cassandra output operator and the Cassandra input operator, which help us to enrich that data. At the same time, those events are actually archived on the HDFS. So it just basically we kind of have a existing implementations from the Malhar library, as well as which basically helped us to finish this use case, implement this use case end to end within almost like a 2 months time. So this is pretty much complex use case which we wanted to finish, and I think without DataTorrent RTS and the Apache Apex platform, it would have been much difficult to finish it in the 2 months. So yeah, that's it. There are some resources here. So I think to know more about the Apache Apex, you can go to apex.apache.org. At this, there are certain links about the documentation. Please feel free to join the user group or the Apache Apex, as well as the you can also visit the DataTorrent website where you can find the various resources regarding Apache Apex as well as the DataTorrent RTS. We just had a we just released the our 3.9 version today, and so we also came up with the fraud prevention app, which is first kind of a out of the box application. So if you are interested in those area, please feel free to reach out to us. And uh, yeah, that's it. So I'm done with my presentation. So if you have any questions, please raise those questions in the questions panel, and will take up those questions now. So I think if you guys have no questions, so I'll basically close this webinar now. Thank you for attending the webinar. Please feel free to reach out to us if you have any questions on user groups on Apache Apex as well as the user groups on DataTorrent. Thank you very much.